Hello and welcome to our talk, The Industrial Evolution of Lateral Movement. My name is Tal Berry and my co-speaker Tal Maor, the more talented Tal from Microsoft Advanced Threat Analytics team. And what are we going to discuss today? So we'll start by giving some introduction to our attackers model, the financially motivated hacker, and we'll see how they constantly try to improve their business process through innovation. Then Tal Maor will get very technical on specific improvements of the business process in the GoFetch tool that automates the lateral movement phase, and also including very cool demo. Then we will discuss what are the implications of the automation of lateral movement, what it means for attackers, reduced cost and increased velocity, and what are the implications on defenders, what if defenders should do, and how should they make lateral movement hard again, and hopefully we will conclude with some practical recommendations. So there's something to take home with you. Okay, let's start with the beginnings. And hacking has many faces. Different hackers have different motivations. Some hack for political causes, some wear uniforms and hack for their country, and some wear suit and tie and hack for their financial gain, for their bank account. And the hacker as a CEO, because he's financially motivated, he sees himself as a CEO, he gets inspiration not only from Sun Tzu, but also from business literature. And in such business literature, he may find quotes like that from the current IBM CEO. She said that for CEO today, it's all about achieving growth and efficiency through innovation. It's not about product innovation so much anymore, as about innovating the business models, process, culture, and management. So the hacker as a CEO reads that and says, okay, I need to optimize and innovate in my business process. So what is the attacker's business process? What's the process at all? So usually we model the attacker process using the cyber kill chain model suggested by Lockheed Martin, and we feel that for financially motivated attacker, a more suitable term would be the cyber value chain. Value chain is a term in economics that describes the process in which raw materials are processed and become product, and value is added along the way. So in the cyber case, the raw materials are the target details. They're processed with the attacker's so-called assembly line, and in the end, the product is the stolen data from the targets. So this is the attacker's process. Now they want to optimize it. So what they do, the first thing they do, they break this big monolithic cyber kill chain or value chain into different separate value chain, which allows them to get better each one individually. It's easier to optimize smaller problems. So they create three different value chains. The first one is the penetration value chain, in which the raw materials are just the target details and the product is a single infected computer. Then the second value chain is the domination value chain. The raw material is a single infected computer. It's processed to be full access to the network. And finally, actions on data, in which the raw material is the full access to network and the product is the stolen data. And now that they break down this monolithic value chain, they are going to, attackers are optimizing each and every one of these smaller value chains. So the first one, the most trivial to automate, is the penetration value chain. It's already happened. We all know that we should assume breached, and because it's very easy to penetrate to a single computer within the victim's organization. For example, by using web application vulnerability, attacker takes the name of the victim, look up in Google their website, scan it with the web vulnerability scanner. Supposedly they found a SQL injection vulnerability, abuse it with SQL map, and upload a generic web shell. Very easy to automate. And because it's very easy, the attackers get more servers, infected servers than they could use, and this, which means a surplus, and that surplus creates marketplaces. And we see headlines like the one below: a black market is selling access to hacked government servers. Then attackers wanted to optimize the final value chain. And the final value chain is all about taking full access to the network and transforming it to stolen data. And this is really a hard problem, and it interferes with the attacker model, because hard means costly for financially motivated attacker, because it's hard to understand what's interesting and it's hard to find buyers to this data. So let's assume the attacker attacks some pharmaceutical company. They need to be chemists to understand all the formulas there, and once they stole the secret formula, they need to find a buyer that understands that formula in order to sell it to it. So it's really hard and lengthy process, and which incurs additional costs. So attacker innovate in the business model of it and introduce the ransomware business model. So in the ransomware business model, the attacker doesn't need to find a buyer because the victim is the buyer, very easy, and the attacker doesn't need to know which data is interesting and which is not. He leaves it to the victim to find out and decrypt whatever they want. So this innovation in the business model made this value chain fast, ubiquitous, and automatic. So we have on one side, so penetration, on the one hand, is very easy to automate and to get single infected machine in the network. And on the end, when the attacker gets full access to the network, they are able to easily monetize it through ransomware. So what happens in the middle, in the domination value chain? So let's take a look into the technical steps of the lateral movement. And the key to be successful in transforming from one computer to the whole network is getting to the domain admin, the most privileged user in the end. So it's all about getting to that domain admin. So how attackers get to the domain admin? First, from that single arbitrary infected machine, they first need to escalate the privileges locally, become admin, which enables them to harvest credentials from this machine memory. Then they need to guess where to go next in order to advance in some way towards that desired domain admin credential. And once they decide where to go, they actually go there using remote code execution ability, and they do it over and over again until they reach the desired domain admin credential, and then they are able to take over the whole network and all credentials. And for most of these stages, there are already a tool doing that. So to escalate your privilege locally, you can use some Metasploit modules. To harvest credential, probably use Mimikatz. For remote code execution, you may use the WMI interface. And once you get domain admin, to get all other keys, you probably would use some other Mimikatz modules, such as the DCSync. So what's left is only the admin reconnaissance phase. And because it's hard, we said the attacker needs to guess where to go, and guess and having a sixth sense, it's not something that is easy to automate, right? It's something that, maybe a seasoned attacker, a veteran attacker will know, I have a feeling I should go towards that because this is an interesting name of a machine, and I think this is the way to go, but you cannot automate guesses. And this is really the last obstacle of the attacker before fully owning the whole network and automating the lateral movement. And as we saw, all other chains are already automated. So the only thing between attacker and a fully automated, fully owned network, fully automatic to ransomware to gain money is only that admin reconnaissance part. And this is the missing link to automation. And now Tal will show you how attackers get around it.
Thanks, Tal. So the missing link in the lateral movement evolution is the automation of data gathering and extracting knowledge out of it. Bloodhound, that was published last summer, is a good example for a tool that automates the data collecting and making a graph that helps to find the shortest attack path, as Tal mentioned. So how Bloodhound actually works. Assume we have the compromised domain user Bob, and the attackers want to use this user in order to get to the domain admin, but they don't know what's the way. So they collect data on users, computers, and groups in the domain, which will be presented as the edges, as the nodes, and more importantly, the relation between them. For example, if a user is a member of a group or has admin rights on a server, and these will be presented as the edges. So in this example, Bob is a member of the IT admin group, and this group has admin rights on server named server 1. On that server, Mary has a logged on session. It means both. Bob can log in to server 1, find the session of Mary, harvest her credentials, and impersonate Mary. Because Mary is a member of the domain admin, now Bob can become a domain admin by himself. Thanks for the Bloodhound gang for the slide and the research on that. And if you haven't been to their talk yesterday, be sure to catch them in DEF CON. So at this point, we have automation for each step in the ladder movement and the value chain. And the only thing left is actually to teach someone to go and fetch domain dominance using these tools. So for that, we have invoke GoFetch that orchestra the ladder movement automation using Mimikatz, Bloodhound, WMI, or PSExec. And what actually invoke GoFetch is. It's an open source coded, PowerShell coded. It gets the attack path like we saw of Bloodhound and additional payload to run on each machine. And it returns the credentials along the path. For the remote code execution method, it uses invoke PSExec, and to harvest the credentials, it uses invoke Mimikatz. You can configure your own payload like Empire, agents, as we are going to see in the demo, or just harvest the credentials or configure additional or other executables. So the first version of GoFetch was presented just after the first Bloodhound. The alpha version of GoFetch worked from one computer and attacked each machine in the path from that computer. We also saw this year Bloodhound 1.3 that extends the attack surface to Active Directory object permissions, but we won't get into it today. A great tool of Marcel Destar also is doing automation of Bloodhound movement and is not using the predetermined path of Bloodhound, but is doing the recon and the expansion on the fly. After Destar, we published invoke GoFetch as an open source, and this version of GoFetch replicates itself according to the path and execute both the payload and itself to go from one machine to another. Lately, we see more and more integrations between Bloodhound and other backend servers like Empire in order to show the pwned machines on the GUI. So thanks for Tom Porter working with me on that demo. So before the demo, let's understand the setup of the environment. We'll start with user 1, which is already compromised. And from there, we'll use Bloodhound in order to find that path. And we'll see that user 1 has admin rights on client 2, and on that machine, user 2 is logged in. And we can use that user 2 in order to get to client 2, and so on until we get to the DC, and there we find the administrator. So for the demo, we have that agent on client 1, just to verify quick who am I and hostname. So once we have the username and the hostname, we can go to Bloodhound and look for the path. And we find the same path as we saw in the setup. And we can use it in order to use GoFetch, and we use this path as an input for GoFetch. So now we launch the model of Empire, invoke Mimic GoFetch, and execute it on the first oil machine, client 1. So this is GoFetch on client 1, and from there it tries to connect to client 2 and start the path. So we see that GoFetch already ran on client 1. On client 2 in the Empire, we see the IP of the agent, and in Bloodhound GUI we see the pwn machine. Now GoFetch is on client 3 already, and in a minute it will be on the DC. There it will find the administrator and will do the way back home. So the DC is also pwned now, and GoFetch is starting the way back home. And with that, we get two presents. We have the agents on each machine, as well as the compromised user we found on the path. So what's so special with invoke GoFetch? Because it's targeted expansion and it knows the path in advance, it means it doesn't touch additional machines in the network, and because of that it's stealthier and faster. It doesn't need to communicate with a backend server in order to get the commands, but it has the knowledge in the edges, and it knows where to go next. And also, less communication, stealthier. For future work, it will be great to see more code execution methods like WinRM or ATExec, more compromising methods like impersonation. It would be great to see GoFetch works fileless and support ASL with Bloodhound 1.3. Don't look at me, it's an open source, so please contribute. Thank you.
So thank you, Tal, for the great demo. So what are the implications of that? So we saw that the last obstacle for the attackers was that admin reconnaissance, and once it's removed with Bloodhound, the lateral movement phase, the domination value chain can be easily automated. And that means creates industrial revolution. Industrial revolution brings mass production. And what is the product of this mass production? This is domain domination. Now it's fully automated, no manual labor, just use GoFetch or other tools. And what the implication for the attacker? It's cheaper, cost is negligent, just click a button. It's faster, domain dominance within minutes. And as a result, there are many more potential victims now, because some organizations were implicitly safe because the data they had didn't justify any manual operation in order to get it. But when all of this operation is fully automated, it costs nothing. So it lowers the bar, and many more targets, many more organizations now become a viable target. And as it happened with the penetration value chain, there will be many networks that can be pwned and fully owned, and the surplus will create marketplace. So instead of seeing headlines like black market for selling access to hack government server, you'll see access to full network is sold on black markets. What should defenders do? As always with a stressful situation, there are three possible reactions: flight, fight, or freeze. So what does it mean to freeze? It's defenders saying, oh, we just continue to do what we always did. We will hunt manually, have manual incident response, and so on and so forth. So I think this classic Indiana Jones scene really, I see jiggles in the crowd, so old guys like me remember that. So the lesson is very obvious. You can be master with the sword, but when it comes to fighting guns, it's irrelevant. Don't bring a knife to a gunfight. You cannot fight automatic attacks with manual processes, even from the sheer economic perspective. And so another possible reaction is to flight. Say, okay, I understood lateral movement, battle is lost, I can't do anything, it's automated. Let's concentrate on defending the last part of the attack, the actions on data. And let's protect our data using encryption, data access monitoring, exfiltration protection, data leakage prevention, and so on. But we have to remember that there are some attacks on data availability, such as ransomware and wipers, in which the action on data phase is really trivial and very fast. So it's very, very hard to concentrate only in this phase. So some investment is due there, but you cannot leave all your defenses in that stage. So the only reaction left is, unfortunately, we have to fight lateral movement automation. So how can we do that? Since the attackers are financially motivated, we have to hurt them in their pocket, because that's the only thing we can do to deter them. And we need to do so by making lateral movement hard, in the sense, make it expensive again. And how should we do that as defenders? We should reduce our attack surface, make reconnaissance, the attack graph generation process employed by Bloodhound, hard again, by hardening information gathering APIs, such as by using publicly available tools, such as the one that created by Microsoft ATA researcher Itai Grady. You can download them. Make finding the path to domain admin hard again, reduce the number of domain admins. Less targets means longer paths. Reduce the graph's connectivity degree to break paths. Remove edges by applying network segmentation and multi-factor authentication. Now the defender had reduced the attack surface, and they need to detect automation. And this can be done by automatically monitoring access pattern. Access pattern is who connects to what and when, and automatically detect the abnormal rapid path traversal. It's very different from what normal users are doing. And also create in advance some deception, fake shortest path using honeypots, fake servers and client, and honey token, fake credentials to deceive the attacker. And once you detect automation using this method, you should apply automation mitigation. And how do you mitigate this detected attack? You should put traps and bats, dynamic deception along the path traversal, offering a shortcut for the attacker, and the attacker lure the attacker to take this bait and be confined in some honeypot, or use adaptive authentication, just-in-time stepped-up authentication along the rapid path traversal. So instead of making your user input their second factor all the time, do it just in time when you suspect that some automation is going on. So if it's real, the attacker is defeated. But if it's a false alarm, then the user just input their second factor and they can continue. So our last slide, let's conclude what we've seen today. So some attackers are financially motivated, therefore they strive for efficiency. And one of the ways they do it is by automating the lateral movement with tools such as GoFetch. And as a result, manual defense procedure will become obsolete, and you need to fight lateral movement industrialization by reducing attack surface, detecting automation and mitigating it with deception and multi-factor authentication, and use the fact that lateral movement is so cheap for attackers, is also very cheap for defenders. Use GoFetch all the time with your red team and blue team in order to understand your security position and amend your defenses accordingly. So with that, we conclude. Do we have time for questions? We don't have time to questions, so you can come to us after the talk or find us in Twitter. So thank you very much for coming here.